All right. Powers of monomials. It's unit 2, notes 11. So we've already learned how to add and subtract monomials. That's where the base stays the same, right? If you have xy squared, it's going to add or subtract to another xy squared. And just the coefficient or the number will change, but xy squared will stay the same. Now, multiplying and dividing, that is when the exponents will change. When we multiply monomials, you add the exponents together. When you divide monomials, you subtract the exponents. So now we're going to do powers of monomials. So this is when you have a number or a letter to the power and then to the power again. So this is called the power rule. When you have x to the a to the b, you are going to, oops, my pen's not, okay, there we go. X to the a times b. So when you have, and write this down, when you have a power to another power, you will multiply the exponents together. Okay? So the first 6, we have a number as our base. That won't change, so I'm just going to rewrite my base of 3. And then we are going to multiply our exponents together. 6 times 2 equals 12, so I now have 3 to the 12th power. And that's it. Go ahead and do number 2 and 6 on your own. Pause the video here. Okay, you should have done 2 and 6 on your own. Number 2, my base of 9 does not change. I will multiply my 2 powers together to get 16, which is my new exponent. Number 6, I have -8. Don't forget to include that in parentheses. Those are very important for negative bases. And then I'm going to multiply my exponents together to get 54, which is my new exponent. All right, and then same thing down here with our letters. When you have 2 variables, you will go ahead and distribute this exponent and multiply it to everything on the inside. That works with if there's a coefficient in there as well. So let's go ahead and try number 10. Our bases of R and S will stay the same. So for R, I had 9 as my exponent. So 9 times that 3 out here. That will be 27. So my new exponent for R is 27. My new exponent for S, well, it was S squared, but I have to multiply that by my outside 3. So 2 times 3 is 6. So my new exponents are 27 and 6. So remember, all I did here was multiply everything on the inside. It's kind of like the distributive property. All my exponents on the inside got multiplied by this outside exponent of 3. Go ahead and try number 11 on your own. Okay, if you did 11 on your own, you should have gotten that your bases stay the same, right? And then P was 12, multiply it by your outside exponent. That would get you 48. Q was 5, multiply it by your outside exponent. That should get you 20. So P to the 48th power times Q to the 20th power. So just a little note on here. It's kind of like distributing, right? So distribute the outside exponent to everything. Every single number or letter to everything inside those parentheses. Okay, so now we're going to do examples with coefficients, just the number. So you have to raise the coefficient to the given power, and then also simplify the variables with the power rule. Now, the steps might seem confusing. Raise the coefficient to the given power, that's a lot of words. All you're going to do are these steps that we did up here, right? Same thing. So take a look at number 13. We have just 5. We don't have it a different or we don't have it raised to the power of anything. When nothing's there, remember it's always just a 1, right? So if we multiply 2 by 1, you're just going to get 2. So it's just 5 squared. So if there is no exponent there, like how it's just 5 by itself, you're just going to raise it to whatever power is outside the parentheses. All right, and then we have our base of r. We have to do 4 times 2, which is 8. And there is our simplified expression, or monomial. Go ahead and do just do number 15 on your own. So pause the video here. Okay, 15 on your own. Remember, so our base of 3, raise it to the 3rd power. And then also, we should have raised this to the 3rd power, which means we would do 3 times 3, and we get 9. Go ahead and flip on over to the back. So here we have a few different things inside the parentheses. We have multiple variables now. So it's the same thing. Our outside exponent is going to be multiplied to all the exponents that are on the inside. Okay, and again, there isn't 1 on 7, which means it's an invisible 1. And then h squared, we have h, and then we have 2 times 3. For j, we had h to the 6th power, so we do 6 times 3. And there is my simplified monomial. Go ahead and try number 21 on your own. Pause the video here. Okay, for this one, you should have distributed the 2 out to everything inside the parentheses, right? So let's bring down that negative sign. And then we have 10 squared, c to the 18th power, and d to the 2nd power. Make sure you got that correct, and if you didn't, you ask for help. Okay, now we're going to do mixed practice. So we have a lot of things going on here. We are going to put everything together that we've learned over the last 3 sections, adding, subtracting, multiplying, dividing, and the power rule, which we did today. So I'm just going to try a random one. Let's do number 29. All right. We are first going to, before we combine like terms, well, before we do the plus that negative number there, we are going to distribute this 3 to the inside, kind of like PEMDAS, where we start with the parentheses. So if we distribute this to everything inside the parentheses, we will end up with -4 cubed, m to the 6th power, and n to the 21st power. All right, as you can see, this and this match. So those are like terms, which means we can go ahead and combine these, right? So when we have a plus minus next to each other, it gets replaced with a minus. Going back a few sections, now that actually, let's just do that next step. So 4 cubed, we're going to actually have to do 4 cubed so that we can add it with 18 or -18. 4 cubed, that would mean 4 times 4 times 4, which will get us 64. So we have 64 m to the 6th power, n to the 21st power. Remember, when you combine like terms, your like term does not change. So we just rewrite that. That stays the same. And then you just combine your coefficients. So we have -18 minus 64. That'll get us -82. So that is our new coefficient. Go ahead and try number 27 on your own. So pause the video here. All right, you should have done number 27 on your own. and you should have ended with 128k to the 10th power. If you did not, please ask for help.